Hello, I'll be using BurrTools to demonstrate how to design your own burr puzzle. I'll be using two examples. One is a simple six-piece burr, and the second example is going to be kind of a different kind of puzzle. Let's start with the six-piece burr. In BurrTools, when I open it up, it's blank. I'll go ahead and click New, and I'll be defining my first piece. The first piece I want to show you is the actual solution to the six-piece burr. I clicked New, and I'll click Label. I'll call this one Solution. Uh, my system sets it up by default as a 6 by 6 by 6. That's perfect. I don't need any colors for this puzzle, so I'll leave that alone. Now, in the grid here, I'll tilt this so we can see it in 3 dimensions. In the grid here, I will start by drawing my puzzle. You could click, 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 or you could draw that, and you can right click or right drag to erase. For this puzzle, I'll also show another trick. Since I know that every single layer has a shape like this, I'm going to simplify that by clicking the Z here, and then when I draw it, I draw all the layers at once. I can toggle that back off again. So I drew this in the bottom layer, as we see here. I'll move up to the next layer, and I know that this one looks like this. I'll keep on going up the line here. And you'll see that it starts to look like a standard six-piece burr. There we go. Uh, Now, one thing about BurrTools is we have solid voxels, the red one here, and we have variable voxels. If I don't know what the inside of the puzzle looks like, I will be using variable voxels. I'll switch it from this one to this one, and I'll start from near the bottom. Uh, so if I can't see these four, I'll mark them as variable. When I turn the puzzle over, I can't see those four, so they are variable. They might be hollow, they might be filled in, I don't know, so I'll just put them as variable. And I'll just keep on going up the line. Basically, anything that's inside the outline will be variable. And I can verify that by looking around the puzzle. Everything looks good. Everything that I can see is solid. Everything I cannot see is variable. I'll toggle it back to normal here. Okay, so that's what the solution to the puzzle is going to look like. Let's look at the pieces. I'll start with, uh, okay, so what I'll be showing you here is how to generate your own pieces. I'll click New, and the first piece I'm going to show you is, I'm going to call it the minimum. I'll call it Piece Min. And this is just going to be a 2 by 6 by 2, 6 by 2. So it will be just a regular piece. We're on the normal voxels. So I'm going to draw normally anything that I could see on this piece. I know that on this piece, on this piece, these are visible. And on the second layer up here, these are visible. I'll also make this piece a little bit easier. Some people like to have this piece filled in as well. So that's going to be the minimum of these pieces. I'm going to copy this, copy, and I'll call this one piece random. This I'm going to fill in with variable voxels. I click on the second button here, and then I just draw in the holes. You'll see that it fills in on the right here. As I generate these pieces, anything that I put as variable, it may or may not put a voxel there. It's going to give me all different possibilities of where these voxels can and can't be. So that looks good. Now to fill in those individual voxels, I need to make another piece. I'll click on New. This one is special. I'll call this one Voxel. This is just going to be a 1 unit piece, 1 unit in every dimension. It's going to be a normal. Click. All right. So the idea is we have this one normal voxel, and we will fill it in all over the place here. There seems to be 10 spots where we can put it. When I go to the next tab, Puzzle, I can click on New. I like to give this a name. We'll call this Piece. So the way this works, we have the name of the problem up at the top, and then we have to describe the problem down here. The first thing I need to describe is what this overall problem is going to look like in the end. I'll click on Piece Random and Set Result. Then I need to define what makes up this piece. That's going to include exactly one piece min. So I'll click on that and then click +1. And it will include anywhere from 0 to 10 of these voxels. I'll click on it once, +1. And then I will click Detail. So it will be anywhere from 0 to 10 of these voxels. I'll go ahead and close that. So now we have this set up. Perfect. We'll move over to the Solver tab. So the way this works, all the different problems that we defined will show up here. We'll be able to solve one problem at a time, make sure that piece is selected. So all of these checkboxes do certain things. One thing that I like to do is do the rotation check. This is going to help remove duplicates. And I will tell it to keep mirror solutions. This is optional. We'll have more results if we keep mirror solutions. If I don't check it, it will consider a mirror to be a duplicate and we'll skip it. So that this looks good. The next thing, people say it's a good idea to prepare. That will clear out anything old. Perfect. And then we can click actually. I'd like to change the limit to something much higher. I like to set it very high. 10,000, 100,000. Great. That just ensures that if we get more than 100 solutions, we get to use them all. I'm going to click on Start, and we're going to get to see it came up with 124 possible orientations here, and I can show you those too as I drag this across. You'll see it shows all different permutations of having one or more voxel, all the way to having all voxels. There are some examples where a voxel may float in midair. I don't know if I can pick one. Maybe too difficult to pick one, but the idea is it's here. It's going to show some examples where this voxel is floating in midair. We don't even have to worry about that because the next step is going to ensure that that is not a problem. The next step, now that we have 1,024 solutions here, we're going to go to File, Import Assemblies. So we get to say what the source is. That's the problem that I defined called piece. We get to say where we put these 1,024 solutions. It's either, well, it's in this case, it's going to be add shapes to a new problem. I'll check that. And I can define my range minimum and range maximum. Minimum means, well, it has to be 0. If I had it anything but 0, 1, 2, or 3, it's going to say that each of these 1,024 pieces needs to be part of the solution. Obviously, it can't be, so 0 is correct there. Range max determines if we allow duplicates or not. At range max, we will absolutely not allow duplicates. It's going to be every piece is unique. If I set it to range max 6, then we might have a possibility where all 6 pieces could be unique. So we'll keep it 0 and 6 here. As far as the checkboxes, in this example, I'm going to check the box for drop all non-notchable shapes. Notchable and millable, that's going to be, depending on how you are making these puzzles, you may want to check these boxes. Some puzzles may just be very difficult to make if you can't get your tooling in the crevices. So we'll have fewer results. The computer will handle it better if I check that box. When I continue, it's going to make a brand new problem, and it's going to add these in. It's also going to remove identical shapes and disconnected shapes. I mentioned about the floating voxel. That will solve that problem. I will click continue. So I'll go back to the puzzle tab, and we see that we have a brand new problem called P2. Currently, it has no result. Again, the result is what this problem is going to look like when it's done. And in this case, I want the full solution. So I will click solution, set result. And now I know that this problem will make this puzzle out of all of these pieces. These pieces are already in here. It's perfect. All right, we'll go to the solver tab. Now I'm ready to solve P2. When I click on P2, it's important to uncheck these again, but then I do want to check the disassemble. What this means is the system is going to show all possible assemblies. If it's unchecked, it will show all possible assemblies regardless of whether they can be taken apart from each other. They might get locked in, and that's not very good. So I'll check disassemble. This guarantees that I can take apart each and every possible solution. It's a good idea, again, to click on prepare, and then I can start. I have my limit set high to 100,000. I could go even higher, 1 million. And drop. This isn't useful for this situation, but if I'm overwhelmed by results and I just want to keep 1 out of every 100 solutions, I can set this to 100. If I set it to 1, it will keep every single solution, letting us browse and see what we like. I'm going to go ahead and click Start here. And we see that slowly but surely, we are generating assemblies. No solutions yet. That's very curious. No solutions yet. I couldn't exactly say why that's happening. Let's go back and see if I did it right. So when I click on entities, I can look at my solution, which is made up of that. Every layer looks perfectly fine. We have all of these possible pieces, ranging from a very simple notched burr piece all the way to a full piece. So my entities look fine. My puzzle definition, P2, looks fine. The solution and the pieces, 0 through 6, that looks fine. And my solver, we are starting to see some solutions. That's really good. So let's take a look here. As it finds these solutions, it starts to organize them. We're looking at solution 1 right now, but if I drag it to the right, we'll see more solutions. These are going to be ordered by moves for complete disassembly. As I scroll to the right, we'll see more complicated solutions. What I mean by that is right now it's at the far left, a rather simple solution. And I can see what that solution looks like as the pieces move right below. I'll drag this to the right. And it looks like these just fall away and these just fall away. Simple solutions aren't very fun, so we'll move to the right and see something more exciting. The number down here represents how many moves for the first piece out and how many moves for all the pieces. As I move it here, I see that currently the most complicated solution is 11 moves. Seems like 4 to get the first piece out. Let's see what that looks like. That was pretty complicated. That looked very fun. Perfect. Okay, so I like that. Uh, once we, I mean, it's going to run for 177 years. So after a while, we just have to settle for whatever it's given us so far. If your puzzle is simpler, it'll run for minutes rather than years. I'm going to stop it right now, and we'll see what we have to work with. Again, if I slide it left and back to the right, we'll see the most complicated solution at the right. If I want to sort by disassembly, I can. I believe that's what it is right now anyway. And if I want to see by level, I believe this is the first piece out. So there's a solution that has 5 moves to remove the first piece. That was fun. Okay, so let's stick with this one. Let's see what I know about this one. It's going to use 2 S11s, a 25, and then 3 36s. Well, that's fun. Um, we could just call that good. We can look at 36, 25, and 11 by clicking on entities. 36, okay. 25, okay. 11, okay. Well, those look nice. Great. So we could just say those are great puzzle pieces, but that's not enough for me. We're going to make a new problem. I'm going to use the same solution. I will pick 11, 25, 36. I believe it was 2 11s, so I'm going to click on the 11 down here, 2 11s. Click on 36. I believe there were 3 36s. And perfect. Now I'm going to go back to solver, and I'll try and solve puzzle 3. I like to do this because even though it's telling me that that's a very good puzzle, if I make the puzzle myself, I might find that it's not all that good. And I'll tell you about that in a minute. So we'll click on prepare, we'll click on start. And it shows me that there are 61 solutions here. So the most complicated is, well, I suppose these two are the most complicated too. We can see that they solve like this. The problem with this puzzle, though, is if you were to create these pieces and say to somebody, go ahead and put these together, they might put them together in the most simple way where they just fall apart, even though your goal was to have them solve it complicated. So even though this looked like a good solution to us, it's not really a very good solution. Um, what you can do about that is just keep looking. So we go back to puzzle 2, and I wasn't satisfied with that. I can click continue on puzzle 2 and continue to let it churn here. So if we give it some time, it's bound to come up with more solutions. It's bound to come up with solutions that we like. Unfortunately, these two weren't very good. We can try something simpler here. 11, 21, 21, 25, and 36. Let's see what that looks like. I'll go back to my puzzle 3. I'll click on puzzle 3. So I think it was 11, 21, 21, 25, 36. Nope, let's look. 11, 21, 21, 25, 36, and 42. And 42. All right, so that's my new puzzle 3. I will click puzzle 3 here. I will make sure disassemble is checked. It's still solving puzzle 2. I'm going to have to stop that. Stop. Now I'll go back to puzzle 3. I will prepare. I will start. So this is a little bit better. Now there are only 12 solutions. We still have a problem where if we hand this to somebody and say, solve it, they might go with the simplest solution, which is actually still pretty complicated. That's still enjoyable. Or, oh, this is a good a good thing to demonstrate here. So it's telling us that there are 12 solutions, but I actually know that there are not 12. When I click on puzzle and then define the problem for puzzle 3, nope, nope, there are. Okay. I guess the pieces are just so similar that they could be interchangeable. So yeah, we have 12 ways this can be put together. Luckily, each of the 12 ways is equally as challenging. So yeah, you might choose that this is a good puzzle to go with. If you don't like this puzzle, you can always continue here, sort through these, and see if there is something else that you like. There's bound to be something. All right, so that was my simple demonstration of a regular 6-piece burr. The next one I'd like to show you is something like this. We have what is this? 1, 2, 3, 4, 6 by 6 by 5. This puzzle is going to have 4 unique pieces that go in the middle and a frame with random placings inside here. All right, let's take a look at that. So I'm going to click New, File New, and we'll stick with the default. So I'm going to click on Entities, New, and we will go ahead and set up this. I'll call this one, let's actually start with the full solution. Okay, this puzzle is going to use colors. Does it need to use colors? No, it doesn't, but I will use colors. So I'll start by defining the solution. I clicked on New, I'll clicked on Label, I'll click Solution. And as I mentioned, this is a 6 by 6 by 5. Great. I mentioned in the other puzzle that, actually, let's go ahead and do those colors. I'll just set up 4 colors. If your puzzle uses any colors at all, then you won't even use default. Default is a choice that you can still choose even with your colors, but I find that once you start using colors, you should stick with it. So I added color C1. We'll keep on going. Okay, I'll just use these as I need them. So first of all, I will show the outer frame. Just like the last puzzle, when I click on Z, I can draw in all layers at once. I could draw it like this, or I could draw the whole thing and then erase out the middle. That looks pretty good. Perfect. So that is the solution. And I know that the top and bottom, I'll go ahead and fill those in. I know those are also going to be solid voxels. I'll say that they are yellow. Bottom is yellow, and the top is yellow. Oh, I forgot to uncheck the Z. That's all right. Well, I'll keep the Z checked so I can get rid of this. Now I will uncheck the Z. We'll do a bottom yellow and a top yellow. Once I start using colors, I also like to check down on the very bottom right corner. That shows me my colors. Perfect. So the inside layers, because I don't know what they are, they're going to be variable. And because I'm using colors, I'll make those red. So I'll click on red. So variable, red, and I will fill in the 3 inside layers. 1, 2, 3. So we'll just keep this to the side. That's what my puzzle is going to look like. The next thing I want to do is define my pieces. My piece shape is pretty simple. And I know that my piece shape is going to be yellow at the top and bottom. And since I'm using colors, I will use red inside. So I'll click on New, and I'll call this piece. And every piece is the same. It's going to be 2 by 2 by 5. So the bottom is yellow, solid. I know it's solid, so I'll do that. The top is solid. And each line down the middle, we'll just do a single 1. Oh, in red, I'll do 1, 2, So each piece will look like this and will fit into the solution however it needs to. The next thing I'd like to do is show you how I'm going to make this random. So I will start with a frame. We'll click new. That's also going to be a 6 by 6 by 5. So I'm going to call this frame min, just like when I did the piece, frame min. This is the bare minimum to make a frame. My frame will be green. I'll click on the Z so I can draw it in all layers. 1, and then erase the middle, 2. That was easy. I'm going to copy this, and I will call this frame random. So this is a copy of frame min, but now I will fill it in where I have random boxes. They will be red, and because they're uh, unknown, they'll be variable. I'm not going to put anything in the top and bottom layer because those are my yellow pieces, but inside could be anything red. So I see I have Z checked. I'll go ahead and uncheck Z. So I'm going to be working on my layer 2, 3, and 4, and I just want to draw along the outside here. I don't want to put anything in the middle. It's just going to be better this way. 1, let's do that. 2, and 3. And just like the 6-piece burr, I need to make a voxel to fill in these middles. Let's go ahead and do that. That's new. Call it voxel. I'd like to stick with red as my color, and these will be solid, and this is just a 1 by 1 by 1. Check it. Okay, it's important to save your work. I didn't show that in my first example, but it's important. It's important because the program might crash, and you don't want that. It's also a good idea to save multiple copies of your work. I'm calling this test 1, but as you work, you might want to call it test 1 and then test 2, then test 3, so you can always revert back to previous states. All right, so I have my voxel set up. Now I can start defining the puzzle. I will first define the frame. Click puzzle. I will click new. I will call this frame by clicking label. My frame is going to look like this. I have puzzle frame. I will choose frame random as my goal here. Fill it in with a frame minimum. So I click frame minimum +1 and frame voxel +1. And then I have to look at detail. So what this means is for this puzzle frame, my goal is to make frame solution out of exactly 1 frame minimum. So exactly 1 is a minimum of 1, maximum of 1. And my voxels, I definitely need at least 1 voxel. In my opinion, maybe I need 4 voxels, six voxels to make it interesting. And a maximum of, how many is this? 1, 2, 3, 4, 5, 6, 7, 8. Maximum of 36. Let's try that, 36. This could be pretty overwhelming for the system, but we'll see what this looks like. If we wanted to have something that the system can generate more quickly, we could make this more like 4 minimum, 4 maximum. It will still take a very long time, but it'll be more reasonable. I'll click on close. Perfect. So we have the problem set up using a frame minimum and anywhere between 6 and 36 voxels to fill in the middle. All right, so we can, another thing I want to point out is our colors look perfect. Green to green, yellow to yellow, red, purple, it's great. We won't go any further. I will click on solver. We have our problem chosen here. I don't want to have this checked. I do want to put expensive rotation check, and we will not keep mirrored solutions. Perfect. So the expensive rotation check is going to be if it determines that there's exactly one voxel here, it's going to know that the puzzle is identical to a similar puzzle where the voxel is here, or here, or here, or even on the bottom row, here, here, or here, here. It's going to help reduce duplicates. So I believe this is going to be pretty overwhelming. We will click on prepare, and I will save my work again. Then I will click on start. When I click on start, you'll see that it is not doing anything. Surely there must be a reason. One reason is maybe I'm impatient. Another reason is maybe it's because I chose a minimum of 6. While it runs, I'm just going to look over my puzzle, make sure I did everything right. So on puzzle, I'm making frame random. Looks good. Out of frame minimum. That looks good. And several voxels. They look fine. Things I'm looking for would be if I got the right colors. I did. And the right, whether they're variable or solid, that looks right too. I'll go back to solver here. It has still found nothing. I don't like that. I'll go ahead and stop it. I'm curious what happens if I take the check out and start, prepare, and start. When it says 7 days, 8 days, it really is going to take a long time. So sometimes years, sometimes centuries. But I'm surprised I'm still not, oh, there's something. That's all right. It's actually quite a nice looking puzzle. So with the expensive rotation check checked, I would probably have seen results. It just would have taken quite a while. So far I have 65. Oh, it's really growing here. I can check what these look like as I scroll across. It's interesting. So far it seems to be putting them all just in the middle layer. But if we give it time, we'll have a lot more choices than that. I'm going to let this run until we have maybe about 500 solutions here. And I can scroll through and see what they look like. Oh dear. That's not very interesting at all. So it took quite a while to get to this state. I think as soon as it goes higher than 349, we'll start to see solutions on other layers too. I don't know if I'm that patient though. If you are that patient, you should let it keep going. I'm not that patient, so I'm going to stop it. So when I stop it, I will have all 349 solutions to work with. And just like for my 6-piece burr, I'm going to click File, Import Assemblies, and I will send these into their own new problem. So the setup for this is going to be similar to the 6-piece burr, except my range, 0 is perfect, 1 is perfect for a maximum. Since I'm doing random frames, I definitely don't want more than 1 frame. I don't think we have to worry about disconnected shapes. Oh, but we'll keep that as it is. And I don't care too much about millable or notchable. We'll just leave that as is. We will remove identical shapes. That's perfectly fine. When I click on continue, we have a brand new problem to look at. I will click puzzle, P2. This does not have, oh, look at that. This puzzle does not have a solution yet. So I will click solution, set result. The rest has been done for me. Another important thing to look at here is the colors. If I were to try to solve this without defining the right-hand side, it may crash. So I'm going to color by color. I'll make sure it's on green, green, and click down. Yellow, yellow, click down. Red, red, click down. Purple, purple, click down. Let's go ahead and save this before we get any further. Now when I click on Solver, I can try to solve for puzzle P2. It's important to check disassemble. Otherwise, it will show possibles where the pieces just won't come out of this, especially a shape like that. The pieces could be in there, but they have no way to come out. So I click disassemble, I click prepare, and I click start. And since I was rather impatient, out of all of these placements, none of my puzzles can be solved. So I go back to the frame, and I guess I just have to let it keep on going. Continue. So I have faith that eventually I'll have more than 349 solutions. While it's running, let's take a look at some reasons why this wouldn't work. So a puzzle like this, if I were to put my pieces in, the piece that goes in this corner would be fine. If the other pieces are already in the puzzle, maybe it wouldn't be able to drop in or out, I suppose. I don't know. Let's go back to solving. Ah, good. So we have more possibles here. We saw what the first set had, and it ended roughly here. Now that it has continued, we have some that have voxels on different layers. I think that's what we need. Ooh, it's really moving. So I'll probably stop it once we get to around 13, 14, 1500 maybe. Oh, I realized too this was still checked. The frame does not need this checked. I'm just going to stop it and continue. Stop it, continue. Just so we're not looking to see if it's possible to disassemble. So we can look through these and see that it starts to look pretty exciting. Let's say this is enough for now. I'll click on stop again. And even though we did this once already, I should be able to do it a second time with the file, save, file, import assemblies. Source is frame. And I should be able to add shapes to an existing problem since it already made one. I'll choose P2. Everything about this is still fine. Click on continue. And it's going to remove identical shapes. So even though it did it once already, it should be okay. I'll click on puzzle, click on P2. Everything still looks very good. So we even have the new solutions. I will click on solver, P2. Now I have to click disassemble again, prepare. And let's start this out. Last time, I believe it just said there's nothing. This time it says there's nothing. That's a shame. I think that means we have to keep on going. Back to frame, back to continue. but you get the idea. So this will continue finding more solutions, I suppose. I'll go ahead and make sure I set everything up correctly. Half the time, if you're having a problem, it's not set up correctly. So I see that my P2 has the solution. Let's see if I have the solution defined correctly. When I click on entities and then solution, I have, oh, okay, that makes a big difference. I think I forgot to add my pieces. So let's go back to puzzle. P2 is the full solution. I need to add 4 pieces. Click on piece. Is this still solving? Let's click on solver. Stop. Let's go ahead and add these into file, import assemblies, frame to P2, add to an existing problem. Hopefully that removes any duplicates, maybe. But now I have to fix my P2. I'm going to go ahead and save my changes. Oh, it is slow. I've slowed this thing down to a point where it crashed. Yikes. Yikes. Okay, okay. Let's open it up again. All right. So I think my solver is still running on one of these. No, it's fine. Okay. So I did a bad job here. We have about 354 frames. That's fine. Just leave that alone. Oh, here they are. Okay. Yeah, that's fine. That's fine. So what I did wrong was I should have added 4 pieces. I clicked on piece, +1, 2. Well, where is it? 3 and 4. Okay, now when I click on solver, P2, disassemble, prepare, save. It's always a good idea to save and start. Okay. I'll have to stop it. Because I reloaded, I lost my limit here. I like all the solutions. I'll click on start. So just like my example of the 6-piece burr, it's going to show all solutions. At the far left, it will be the most simple solutions where I would say a piece just comes out. That's not fun. No one wants that. So let's go to the right. This could be fun. Okay, so it says 22 moves here. That's fun. Let's see what that looks like. Down here I can drag. Oh, was that fun? That was fun. Okay. Set. And it's done. Okay. So of these frames that I chose, at the far right, this was, in my opinion, the most fun, but there were others. This was nice. So this is frame S75. Now, just like my example of the 6-piece burr, I'd like to find out if this is actually fun. So I'll click on puzzle, make a new problem, add 4 pieces, well, set the solution, add 4 pieces, 2, 3, 4, and what was S75? So for puzzle 3, my test, find 75. That's my frame. Add it. So let's find out if this puzzle is fun. Solve it and try and solve puzzle 3. Prepare, start. Okay, so this is what I want to see. For this puzzle, there is only one solution. That means it's fun. So let's look. It solves, that was fun. I'll be honest, it's more fun when all the pieces have to move around, but this is a pretty good start. If you want something that's even more fun than this, you probably want to make more frames. Uh, let's take a look at what that frame even looks like. So, so this is what the frame looks like. Let's zoom on the right, just drag the wheel. Okay, that's pretty nice. That's pretty nice. So let's say I like this puzzle, and I know that this puzzle requires 22 moves, 7, 6, 6, and 3. One thing that you might like about puzzles is uh, either having it as sparse as possible or as full as possible. So let's see what happens if I start modifying this frame. So I'm on S75, and I can see layer by layer, this is what it looks like. This one is interesting that only the middle is filled in. So if I want to kind of complicate this a little bit, I might want to start adding more voxels and see what happens. So to do that, I'll change my color. I'll change to normal voxels. Let's see if this is still solvable if I put a voxel there. No, it's not. Take that out. Try this one. Still not solvable. Maybe here. No, not solvable. Was it that is? No, no. Here. Ah, that's still solvable. So yeah, we could still have a fun puzzle, and if we're very careful, we can add voxels, and it will still be solvable in exactly the same way, but it will just be more full, more solid, and just maybe more comfortable to solve. Or, well, let's look at some other layers too. I'll go ahead and put one right here and see what that does for a puzzle. It's still basically solvable. So that's a matter of opinion. If you like a nice full puzzle, you can trial and error fill these in, try and solve, then go to this layer, do the same thing, fill these in, try and solve. And you may find that it either makes the puzzle more complicated, might make it easier, but it will make it fuller. Sometimes that's a nice goal to have. All right. So that's all I have for you here. Hope you enjoyed.